Hello. Today, we will talk about real-time 3D rendering to get nice-looking images inside derivative Touchdesigner. We will create a very powerful and flexible system with buffer techniques to have a maximum control over our final result. We will learn how to set up a pretty simple rendering system to obtain some nice color informations about our 3D scene. That's what we call buffers. I know, these images look like crap, but I promise they can be used in many ways. This tutorial is based on a workshop my puppeteer gave few years back at Stereolux in France. The project files are available since then, for free, both on community section on Derivative's website and on my Puppet Master's Patreon. But, even with that, you still asking some questions about the process, so that's why I'm doing this tutorial today, for your lazy ass. Let's dive in. I'm ready. Are you? First thing first, let's import a 3D mesh from our hard drive. File in SOP. Try to choose an object with textures. Mine, for this example, is a model from Dan Simonic, downloaded on Sketchfab and contains color map, normal map and occlusion. Create a null SOP. Right-click on the output, Geometry Comp. Rename this to Man. From your Explorer, drag and drop the 3 textures to automatically create 3 movie file in top. Now, APBR matte. Metallic and roughness to half. And, in the Maps tab, drag the normal map to Normal Map. Bump scale at 2. For now, that's it for the material, we will come back at it later. Select the Geometry, Render tab, PBR1. Create a render top. I choose a resolution that fits the aspect ratio of this tutorial. Put what you want. For now, we are missing camera and lights. Take the camera viewport from the palette. The render top is render 1 and the container is the one above. Camera is camera viewport, geometry is man, and turn off anti-alias. Okay, good. Create a first light comp. Shadows tab, hard shadows. Increase the size of the shadow map. Duplicate it, and choose different position, orientation, and color. And finally, an environment light comp. Create a white constant top and drag it to the environment map. Decrease the dimmer parameter. Perfect. Now we have a simple render system. Let's create our render buffers. They have to be activated in the material. Select our PBR, Advanced tab, and create maximum number of buffers. We would like Final Diffuse Color, Final Specular Color, Texture Coordinates, Camera Space Normal, World Space Normal, World Space Position, Emit Map. Go back to the Render. Advanced tab. Increase the number of color buffers to 8. And some of them require a specific pixel format, 16 or 32 bits. Let's say 16 is enough, here. Create a render select top. Color buffer index, 1. Copy and paste, multiple times.
I'm so stoned right now.
Each render select should have a different index. And boom, these are our buffers, nice. Create some null tops. The first one, from our main render can be called Beauty, but we will not use it. Then, Diffuse, Specular, UV, C-norm, W-norm, POS, and OCC. This last buffer is still black, which means empty. Go back to your material and drag the occlusion map to the emit map parameter. That's it, we have our occlusion. Last but not least, create a depth top, pixel format on depth texture and rename it depth. Oh no, one more thing. A low poly wireframe effect, of course. Create a polyreduce SOP. Keep, let's say, 3% of total polygons. Right-click, Geometry Comp. Rename this Wire. Let's dive inside. Turn off the flags on the out SOP. Create two material SOP. Activate their render flags. One will be a PBR matte mode wireframe, and the second is a constant matte black. Because the two SOPs are perfectly aligned, and to avoid Z-fighting, go to the Common tab and activate the offset factor to 0.5. Go up. Second render top. Camera is still camera viewport and geometry is wire only. A final null top. Rename it wireframe. You can see some artifacts all around our image. That's because of the shadows. Our wireframe geometry should not cast some shadows. Go to your light comp and, in the shadow caster parameter, write man. Oh, here we are, bitches. We finally have all our buffers. Few words about the buffer we've just created. The final diffuse color is the general color of a material when light shines on it. The final specular color create the bright highlights that one would see on a glossy surface, mimicking the reflection of light sources. Unlike diffuse shading, specular reflection is viewpoint dependent. It's important to notice that if we add diffuse and specular, the result is equal to the main render, the beauty. The texture coordinates represents the UV, the different positions of a texture on a mesh, depending on how it has been unwrapped. This buffer will give us the ability of putting some new textures afterwards. Camera space normal and world space normal represent the orientation of the faces, in both camera space and world space. The main difference is the camera space normal is viewport dependent. The world space position gives every pixel the color of his absolute coordinates in the 3D world. The emit map will provide a constant render of our object while a specific color map, in our case, an occlusion texture. The depth image is all white for now. But don't worry, it contains all the information we need. The distance between the surface of our object and the camera. It's time to present the tools my Puppet Master created to use these buffers and their different properties. I repeat, you can download them for free, link is in the description. I will explain how these different tools work. These tools can be sorted in two main families, color and masking. The true power of the technique is the way we will combine them later. The workflow can be summarized like this. We create two materials, and they will be partially revealed through a mask. An easy way to create a huge variety of blends and advanced new materials. The fast matte gives us the ability of recreating different kind of materials showing different levels of specular reflection, depending if we drag diffuse or specular buffer to it. The UV image allows us to wrap new texture images on our 3D model. Let's create a noise top, not monochrome, change parameters. Create two select top. Take the specular buffer and the UV buffer. Now, a remap top. Plug our color texture in the first input, the UV buffer in the second input. We have a new texture on our mesh. Now let's multiply this with specular buffer. Create a level top, increase brightness a little bit, and a multiply top. Wow, we have a new shiny material. Just to be sure the system is okay, duplicate all this shit. Bring back the original color texture. This time, take the diffuse. Plug. Okay, our sculpture looks totally different now. The Fast ENV tool simulates a reflective surface within custom image environment. You can rotate and blur the input image to obtain different results. For that, again, we also use the remap top, but instead of UV coordinates, we use in the second input the camera space normal. Create a math top, because we need to rearrange from -1, 1 to 0, 1. Create a transform top. extend repeat, and move the transform parameters. To go further, optionally, we can multiply the result with the occlusion to avoid reflections in the cavities of the model. You can also insert a level top to adjust the result. Normal mask. The main purpose of this tool is the creation of a black and white mask, depending on normal information. Here, the result will be really different if you use world normal or camera normal. World space normal will select all the faces pointing in the same direction. Great to create masks like moss usually grows on the north side of trees, or snow effects, for example. Camera space normal is the way to create Fresnel effect, or every material changing color as we move. To do that, select top. Choose the buffer you want, W norm or C norm. And 3 threshold tops, 1 for each color, red, green and blue. The comparator should be on not equal. Then, a composite top, mode multiply to get the intersection of those 3. And a level top to boost the brightness. The threshold values and the soften will create a huge variety of black and white repartition. World mask. I really love this one. You can easily create a mask that will stick to a position, even if the camera is moving. You can choose the center of the mask and the size for the 3 world axis. Exactly the same method. Select top, 3 threshold top, comparator not equal. The threshold parameter defines the center position and the soften, the size. The UV paint and UV picked are based on the same method. We can draw or project pictures directly on our model. This time, we need the UV buffer. Select top. UV. We create a feedback loop to keep the track of your mouse movements, then apply it as a texture with the remap top, like we saw earlier. The final result is a mask that wraps the model perfectly. It's now time to create our final image. I will show you how to create the one I used for the teaser. First of all, create a fast matte with the original texture, define a diffuse-based rocky material. Create a null top. Right-click, collapse selected. Import an image, movie file in top, it will be our background. Over top. Let's go up and rename this base, background. You remember, I told you to deactivate the anti-alias in the render. That's because some render buffers need this. Easy to solve. Create an anti-alias top. Quality Ultra. Alright. Another fast matte. This one will be a shiny and glossy colored metal. Create a pause mask tool. Define a zone at the bottom. Matte top. OK, create a fast ENV. Use one of the default equirectangular image from the TD folder. Blur it a little. Create a norm mask with the camera normal. Use the blue channel to create a nice Fresnel effect. Multiply top to combine those 2 outputs. Add top. Plug everything. Oh, that's nice. Let's add a wireframe above that. Take a new pause mask. Select top. Wireframe buffer. Multiply top. Maybe a level top to slightly decrease the opacity. Then, composite top, screen mode. Boom. Play with the previous position mask to precisely choose where your wireframe will be. Another fast matte. We create this time a kind of copper material, based on specular buffer, with a noise top and a level top, to make it orange. Create a norm mask, this time with world normal. We try to limit the mask to the man's back. Multiply top. Over top. Last but not least, a small depth of field. Create a null top. Right-click, collapse select. Rename this base as DOF. Dive in. Select the depth buffer. Threshold top, not equal. Threshold will define the focus distance. Add just a little bit of soften. Add a level top to make it a little bit brighter. Luma blur top. Increase the black filter width to something around 20. Right, okay. I think that's it for today. As I said earlier, there is plenty of ways to combine these tools. You can obtain some much different results. You don't have excuse anymore for not creating amazing renders inside Touchdesigner. I would like to thank all the patrons who support my Puppeter, and especially these ones. Go visit it, you will find some exclusive project files, and some files are available for free. Otherwise, you can also find my Puppet Master on social medias.